I shortly wanted to present a small piece of software which I've written for a university project. It's basically a real-time Voronoi shader, which is calculating the Voronoi cells for a given set of points we have. That's here on ShaderToy, where I've initially written the shader, and basically we define a points array here where we store all the points for the Voronoi diagram. Then here we have our basic Voronoi algorithm where we iterate over every point in the array and check the minimum distance to the current pixel we are looking at. The currently pixel is equal to the UV coordinates we are calculating over here. And when we found the point with the minimum distance, we calculate a proper color for it. So it's basically resulting in 4 different cells with different colors, which are representing the Voronoi cells. And the next step for the university project we are currently working on was to include that into our GUI application to make it usable with C++. We've worked with Hello, I'm GUI as a GUI framework to generate our C++ GUI. And Hello, I'm GUI has an option to use SDL as a graphic backend to generate the graphical user interface. And for including the shader, I've also used SDL to properly load the shader and then render the content of the shader into a render texture. That's a lot of code here, but I just wanted to shortly run the application to demonstrate how it's all working. Basically, I started our GUI application here. Now we select GLSL shader. You can see the result here, which is basically a blue image because we don't have given or passed any points to the shader. And when I click here, you can see that this list with the points is expanding, and we also pass the proper points to the shader. And on the right side, you can see that we generate the Voronoi diagram for all these points in real time. I just made the points moving a little bit, so you can see that it's running very smooth, several frames per second. That's basically our simple experimental approach for a GLSL shader in our GUI application, which is rendering the Voronoi diagram in real time, which is way more faster than the other methods we tried to use for CPU computation.